Hi, folks. In this lesson, we're going to learn how to solve simple equations. Hopefully, this is something you learned in middle school, but it's going to be a skill we use all year, and so we're going to review it. First, we need to know some vocabulary. A variable is a symbol, usually a letter, and X is probably the most common letter used, that represents one or more numbers. Those numbers are typically not known, and then the point of solving the equation is trying to determine the value of this variable. A constant is a fixed value. It does not change. And so if you put variables and constants together, you create an expression, which is just one or more constants and or variables and or operation symbols stuck together in an expression like 3x plus 7. And in this example, 3 is multiplying the variable x. 3 is a constant. And then after you do the 3 times x, you add 7. 7 is a constant. If you simplify an expression, you write it in the most basic form possible. There's no more addition or subtraction or multiplication or division that you can do. And so for this example expression, it's as simplified as it can be. Although there is multiplication to do and then addition to do, we can't do it because x is a variable and we don't know what its value is. And so this is fully simplified as this expression can be. An equation takes two expressions and relates them to each other in using an equal sign. So here we've got that same expression, 3x plus 7, and we have a very simple expression, 13, and we're relating those two expressions together with an equal sign. So when we solve an equation, the goal is to get the variable, to isolate the variable, to get it all by itself on one side of the equation. And so let's have a look at how we do this with some examples. So this equation says x minus 3 equals negative 5. Well, how do I get x all by itself on this side of the equation? Well, I need to get rid of this subtraction by 3. How do I get rid of subtraction by 3? Well, I do the opposite. Instead of subtracting by 3, I'm going to add 3. This is an inverse operation. In order to keep this as an equation, in order for both sides to be equal to each other, I have to continually do the same thing to both sides of the equation. So if I add 3 to this side of to the left side of the equation, I have to add 3 to the right side of the equation. Notice the equal sign is like this invisible dividing line. Left side, right side. I need to do the same thing to both sides of the equation. So when I add 3 to both sides of the equation, I get that x equals negative 2. And I've solved the equation. Now, it's always a good idea to check your solution to make sure that you've done it correctly. This is especially important if you're perhaps a little uncomfortable with negative numbers. Then you can go to your calculator and you can see, hey, if I do negative 2 minus 3, does that equal negative 5? And yes, if you plug that into your calculator, you check that out, you see that negative 5 does equal negative 5. That checks out. Therefore, x equals negative 2 is the correct solution. Let's look at another example. 0.9 equals y plus 2.8. In this example, I want to get y. Y is my variable this time. I'm trying to get y all by itself on one side of the equation. How do I do that? I need to get rid of this adding 2.8. Well, the opposite of adding is subtracting. So I'm going to subtract 2.8 from both sides of the equation. And when I do that, I get that y equals negative 1.9. Notice it doesn't matter whether my variable is on the left side of the equal sign or the right side of the equal sign. It's an equation. The thing on the left side of the equation equals the thing on the right side of the equation. If it makes you feel more comfortable, you can absolutely rewrite this as y equals negative 1.9. But it means the same thing. We can check our results. We can take that negative 1.9 and plug it back into the equation. 0.9 equals negative 1.9 plus 2.8. And we can plug this into our calculator and make sure that it checks out. And it does check out. 0.9 equals 0.9. And so we know that this is the correct answer. The variable y equals negative 1.9. So notice that adding or subtracting the same number on each side of an equation produces an equivalent equation. An equivalent equation, just going back up to our definitions for a second, are equivalent equations are just two equations that have the same solution. So all I did here was I've come up with a simpler equation that means the same thing as the original equation. So in order to create an equivalent equation, you need to use inverse operations. And that's what we did when there was an addition problem in the equation. We used subtraction to get rid of the constant that was attached to the variable. If there was subtraction, we used addition to get rid of the constant. In the next couple examples, we're going to see that multiplication and division are inverse operations. So let's look at some examples there. Solve each equation, check your solution. Negative n divided by 5 equals negative 3. In this equation, n, the variable, is being divided by 5. So in order to get rid of that 5 that's attached to the n, we need to do the opposite of division. We need to multiply both sides of the equation by 5. Now, this isn't the full story, and if you're got a good memory for this from middle school, don't worry, I'm going to come back to that later. I'm going to multiply both sides by 5. The 5 in the numerator, the 5 in the denominator, divides away, so it's like multiplying by 1. And on the right side of the equation, negative 3 times 5 is negative 15. Now, notice I don't have n all by itself yet. I have a negative sign still attached to my n. You have not solved the equation until you get the variable x, or in this case n, all by itself. And negative x is not all by itself. There's still a negative 1 attached to this n, multiplied to this n. So what I need to do is I actually need to not multiply both sides by 5. I need to multiply both sides by negative 5, because a negative times a negative is a positive. If that's too much to think of in one step, I'll just undo that for a moment. And I'll just take this equation, negative n equals negative 15, and I'm going to just multiply both sides of the equation here by negative 1. If you prefer to think of it as dividing by negative 1, that's fine. That also neutralizes that negative sign. Negative 1 times negative 1 is a negative times a negative is a positive. A negative divided by a negative is a positive. We now have n equals positive 15. Now n is all by itself, and we have solved the equation. Once again, always a good idea to check your math. Plug 15 in where the n was. We've got negative 15 divided by 5 equals negative 3. And if you check that out on your calculator, it does give you a true statement. Looking at example B, here we've got a lot of symbols. But this particular symbol, pi, is a constant. It has a specific meaning of 3.1415926. It goes on forever. It's an irrational number. It's a constant. We can divide by pi the same way that we divide by 2 or divide by 5. And so if we divide both sides of the equation by pi, 2 divided by 2 is 1. 5 divided by 5 is 1. Pi divided by pi is 1. So I just have one x here. I have x all by itself. Notice I'm dividing by pi because x, my variable, was being multiplied by pi, and I want to do the inverse operation. Negative 2 pi divided by pi. Once again, pi divided by pi is just 1. So I'm left with just negative 2 by itself on the right side of the equation. So my variable x just equals negative 2. And I can confirm this by doing pi times negative 2 equals negative 2 times pi. Well, yes, multiplication is commutative, and so this is a true statement. Please notice that just as negative x does not count as x all by itself, that's x that's been multiplied by -1, 1 over x does also not count as being x by itself. If you think about it, if you have 1/50th dollars, that is not the same thing as having $50, right? That's a false statement. So 1 over x cannot be the same thing as x unless x happens to be equal to 1. And so how do you deal with that? If you have something like 1 over x equals 20, there are a couple of different ways that you can deal with that. You can either multiply both sides by x. So I can multiply the left by x and multiply the right by x. And then x divided by x is 1. And 20 times x is 20x. Okay, so that's one way to deal with it. Another way that students sometimes learn to deal with it is cross multiplication. So you think of 20 as being 20 over 1. So you do the denominator here times the numerator on the other side of the equation, the denominator on the right times the numerator on the left. And so you would get 1 times 1 equals x times 20, which is also still 1 equals 20x. So that's a way to bring x up out of the denominator if you do have a problem where x is in the denominator and you need to isolate x. Let's do an example of a real life problem. So in 2016, Usain Bolt won the Olympic 200-meter dash with a time of 19.78 seconds. Find his average speed in meters per second to the nearest hundredth. Okay, so I want a speed in meters per second. You can kind of tell from that speed is distance divided by time. It kind of indicates that in the units, right? Meters are a measure of distance and seconds are a measure of time. So speed is distance divided by time. And the distance that he ran was 200 meters. And the time in which he ran the 200 meters is 19.78. So notice 200 has units of meters, 19.78 has meters of seconds. And so my answer here will be in meters per second, meters over seconds. If you punch this into your calculator, you get 10.111223. There are lots of ongoing decimals there. It is not sensible to give all of those decimal places for our answer. We'll talk more about this in a later lesson, but the 200 meters is measured fairly precisely. The seconds is kind of only measured to 2 decimal places, so we don't need to go more than 2 decimal places here. We kind of want the number of, they're called significant figures in science, and that's beyond what we're going to do in math class. But you want your numbers to kind of match the precision of what you're given in the problem. So I want to round off my answer about here. When you round, if this number is 5 or higher, you bump this number up. If the number after the division, kind of the cutoff point, is 4 or less, you keep this number as it is. So I'm going to write this as 10.11 meters per second. And then checking your answer just to see if it makes sense. If he's going 10 meters-ish in 1 second, then he will go 200 meters in 20-ish seconds. And that is, in fact, what we see here. So always checking your answer to see if it makes sense, if it's in kind of the realm of sensible answers. Please notice that this equation here, speed equals distance divided by time, is an equation that I do expect you to know, to have memorized, or to be able to reason out if you don't have it memorized. Here are some other equations that I expect you to know. For instance, perimeter, the length of the border of an enclosed shape. So if you've got a rectangle, you should know that you need to do the width times the length. I'm sorry, width plus the length plus the width plus the length. if you want to have the perimeter. For the area, you just do length times width for a rectangle. For a triangle, it's a little more involved. You do 1/2 the base times the height. Basically, a triangle is 1/2 of a rectangle. So it's kind of the same formula as a rectangle, but you do cut it in half. The only difference, or the tricky difference between the formulas, is that you do measure the height of the triangle, which isn't necessarily the length of one of the sides. Volume. Volume is length times width times height of a box shape with 90-degree angle corners, like a rectangular prism or a cube. You should know how to calculate averages. Averages are the sum of all values in a set divided by the number of values. You should know what percent means. Percent means out of 100. So 78.5% just means 78.5 out of 100, like a fraction, which written in decimal form is 0.785. Speed is rate, or here it's written with the letter R, but you could write it with the letter S for speed, is distance divided by time. There are some other formulas that might come up, but here is, and you should be able to reason those out. So surface area is the sum of the areas of each face of an enclosed three-dimensional solid. So if you found the area of this rectangle and this rectangle and this rectangle, as well as the rectangles that are on the kind of hidden faces, this rectangle, and this rectangle, and then you added all 6 of those rectangle areas together, you would get surface area. And so I don't necessarily recommend memorizing this formula, but you should be able to reason it out. If there are 6 faces on a rectangular prism, then you find each of those areas and then add them together. So these are formulas that we will use regularly in this class. You won't be given them on a closed note test, but on open note quizzes, you can have this page in your notes available, and you can access the formulas that way. I hope this helped.